Hi friends, welcome to Example 4 on Unit 4A, Day 1. First what we're going to do is we're going to go ahead and plot these points on the graph to classify it, and then we'll find out what type of triangle it is. It says determine if it's a right triangle. We'll also talk about easy ways to do that. So P is at coordinate 3, 1. So that's here. I know where the triangle is, that's why I'm going ahead and mark P on it. Q is 3, 4. 1, 3, 1, 2, 3, 4. So there's Q, and then R is 7, 1. 1, R. So now I can go ahead and connect these. I'm going to use a straight edge. Even though I can kind of see where it is on the grid as well, it's helpful to use a straight edge to make sure, especially in situations like this, where it's not through the grid. All right. So I need to determine what type of triangle it is by its side. So I need to know the side. I need to know the lengths of all sides. P to Q is really easy. I can count. The grid there is sufficient enough to follow. P to R I can also count. So that's 3 and 4. Now this last side here from Q to R, it's a little bit tricky. The best way to go about doing this is by using figuring out kind of the distance between these. So we're going to be using kind of that distance idea to find it. So what we're going to do to find the distance here is we're going to do that 3 squared. So again, we're counting it. So to find the distance from QR, to find the length of QR. Remember, that's going to be QR squared, is we're going to take distance from PQ squared and the distance from P to R squared. We're going to add them. So that gives me 9, 3 squared is 9, and then 4 squared is 16, so this gives me QR squared is 25. Now to undo that squared, remember we square root both sides, square root, and so we get QR, so the length of QR is equal to 5. So now I know by looking at this that these are scalene. These have 3 different side lengths. So this is going to be a scalene triangle. But what type of triangle is it? It says determine if it's a right triangle. So the easiest way that we can do that is if this follows 2 rules. So we can check either of the 2. We can check if it follows Pythagorean theorem, a squared plus b squared equals c squared, or we can check to see if the slopes of the lines are opposite reciprocals. So let's check that. So from P to R, the slope of this line is 0. So the slope, excuse me, this line segment, I'm saying slope, I'm saying lines, I should be saying line segments. So the slope of P to R is 0. And the slope of Q to P is undefined. Now, because it's undefined, that means it's a vertical line. We know all vertical lines are perpendicular to horizontal lines. So this is, in fact, a right triangle. So triangle PQR is a scalene right triangle. So that tells me that it is both right and scalene. B is a little bit trickier. So with B, we have 1, 1. So this is P, Q, 2, 3, 4, there's Q, and then R is 1, 2, 3, 4, 6, 7, 8, 1, 2, 3, 5. So we have to do a little bit more on this one than we had to do on the previous one. We're going to have to do that squared part, find the distance of each of these, similar to what we did on find the hypotenuse on the previous one. I forgot to mention that we can actually also draw in the right angle, since we know that it's right there for that particular part. All right, so now we're going to find out, is this a right angle? So again, so if I wanted to find the distance of P to Q, so we'll start out with that, P to Q. So remember, it's P to Q squared. I have to go down 1 unit on the graph, so that's 1 squared, plus I need to go 3 units to the right, so that's 3 squared. So PQ squared is going to be 1 plus 9. So PQ squared is 10. So again, then to find this, I'm going to take the square root of 10. So PQ, square root both sides. So I get PQ is equal to the square root of 10. I'm going to leave it as the square root of 10 for now. I'm not going to put that in my calculator. I'm not going to get a decimal. We're just going to leave it as square root of 10 because we want to compare it again to the other ones. So now, making a little box, kind of self-containing my work here. Now let's go ahead and find QR. So the length of QR squared is equal to 1, 2, 3, 4 squared plus 1, 2, 3, 4, 5 squared. 4 squared is 16. 5 squared is 25. Oh, forgot my cube. There we go. And then 16 plus 25 is 41. So then we square root both sides. We get QR, again, is the square root of 41. Again, we're leaving that as the square root. I'm not giving a decimal, not putting it in my calculator, just leaving a square root of 41. And now we're going to find the length of PR. Squared is equal to, let's go, 1, 2, 3, 4, 5, 6, 7. So 7 squared plus 1, 2, 3, 4 squared. So 7 squared is 49. 4 squared is 16. Oh, forgot my squared. So then I have PR squared equals, let's see, that's 65. Double check my math. Yep, 65. Square root both sides, and we get PR is square root of 65. Now, knowing that none of these are the same, because we didn't get the square root of the same number, that means that this is a scalene triangle, because none of them are the same. So now we need to find out, is it a right triangle? So to find out if it's a right triangle, I just need to check the slopes to see if they're opposite reciprocals. Let's check Q. So the slope of line segment PQ, so that's going to be a negative 1/3. So the slope of PQ, negative 1/3, and then the slope of QR is 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5/4. Those are not opposite reciprocals, so this is not a right triangle. Not a right triangle. All right, friends, join me in the next video as we move on to the next part of the notes.